Hello and welcome to 3D Printed Project. In today's video, I'll be showing you how to integrate your 3D prints with custom PCBs and how to design them. A big thank you goes to PCBWay for sponsoring this video and the project itself. This video is meant to introduce you to designing your own printed circuit boards and how to incorporate them with your 3D prints. By no means am I an electrical engineer. In fact, this is my first ever design, and if I can make something like this, so can you. Why am I even making a video like this? Well, as someone who's sponsored by PCBWay, I told myself it's kind of silly that, I haven't even attempted to make my own PCB design. So that is one of the reasons why I made this video. Second was genuine curiosity. How can I take this design that I'm seeing on the computer screen and have it physically manifest itself in front of me? I wanted to dip my toes into this field to see how it can benefit my future 3D prints. You can create a lot of wonderful projects using PCBs. PCBs can be found in your everyday electronics, such as smartphones, computers, LED bulbs, TVs, thermostats, and this is just scratching the surface. Now that you get a picture where you can find PCBs, it is time for me to show you how you can make your own. To start designing a printed circuit board, you'll need to download a software called KiCad. It is a free program released back in 1992 and is still being updated to this day, with the latest update being released in October of 2024. As of now, KiCad is holding a fund drive for 2025, with a goal being $128,000. I will leave the link in the description as to where you can download this program. Personally, what made this a truly smooth experience is that PCBWay offers to double check your design to make sure that it actually works. Here is a video that I received from PCBWay asking if I'm satisfied with the results. Note that this kind of service you'll have to request before submitting your design. Alright, let me show you the basics on how you can start your project. Once you downloaded KiCad, open up the program. Once you open up the program, you're going to be met with a bunch of different tools. We're going to start with Schematic Editor. Here, you're going to be met with a blank page and a bunch of different tools. There's tools on the top bar and on the right side. We're going to try to redesign the PCB shown at the beginning of the video, so you'll have to select the round symbol on the right side. Draw a circle. Also, you're able to choose your units to be in inches, mils, or millimeters. Once you finish drawing your layout for your PCB, you want to be able to add components such as LED lights, battery holders, resistors. To do so, you have to click A, which is meant for adding symbols. A window will pop up with over 21,000 items. That is how many electronic components that you can add to your PCB. Let's begin by searching for a battery. It gives us two options, a battery that can hold multiple cells or a single cell battery. Let's choose single cell battery. Decide where you want the battery to be located. Now technically this is just a symbol, it's not a component yet. So if you were to export this file and send it off to your PCB manufacturer, they're not going to be able to find out what part you actually need. So for us to tell them, we need to assign a footprint. To do so, you right click the symbol, click Properties, go to where it says Footprint. Where it says Value, click the library symbol. Search the battery holder that you're wanting to assign. In our case, it was a CR2032 battery holder. On the right side, you can see the preview of how the component will look like. Click OK. And click OK again. Now that you've assigned a footprint, an electronic component, at the very bottom, you can see which item it is. So also when you export the file, the PCB manufacturers such as PCBWay will be able to assign a proper item to your circuit board. Now sometimes they're not going to have the component you're needing, but they will offer a substitute. Just because KiCad has it in their library doesn't mean that PCBWay will have it. So they will offer you a substitute, which works either way. As long as your final design works the same way that you intended it to work, that's what we're trying to go for. Now that we have a power source, you want to be able to add some LED lighting. To do so, you do exactly as we did with a battery holder. You click A to add symbol, and you search up LED. So once you search LED, there's gonna be a lot of different options available. The one that I found was literally called light emitting diode. That is the name for LEDs. That's what it stands for. Click OK and position them wherever you want them to be. In my case, I had one on the left, north, east, south, and west. So now that you place the symbol, you can also copy them and paste them. And we're gonna assign which LED they're supposed to be. We're gonna follow the same procedure as we did with a battery cell. You will select your symbol, right click, properties, footprint, click value, and then click the library symbol. Now, the LEDs that I used in my video, in my project, were 0805 LEDs. They're just rectangular red LEDs. Actually, you can specify which color you want later when dealing with PCBWay. You can tell them which color you want, but you have to make sure. One thing I learned by making this project is that different color LEDs will consume different amounts of power. So you have to assign a proper resistor to this particular LED. In my case, we're gonna do add symbol again, search up resistor, resistor. Oh, there you go. Yeah, so you find a resistor. You can also flip them like this. There you go, by choosing rotate clockwise symbol on the toolbar. And as with the LEDs, copy and paste, rotate if need be. Same with the LED lights. And you can see that they're also getting numbered as we go. Now that you finished laying out where the resistors and the LEDs will be, let's not forget to assign the footprint to resistors. So same way, right click, properties, footprint, values, click the library symbol. Now search up 0805 and you're gonna find a resistor somewhere down below here. There you go. This will be your resistor. Click OK once finished, and don't forget to assign all of them. Every resistor symbol is now associated with a physical component. All right, let's begin by running traces from your battery to your resistors to your LEDs. Click this add wire symbol. Okay, and join the battery cell to your resistor. From the resistor, join it to your LED light, and your LED light does have to go back to the battery. Okay. As you can see, this is the positive side, this is the negative side. So do the same for the rest of them. Again, I'm just doing this really quickly. I believe this will work also. Let's give it a shot. Now let's find where it says electrical rules checker. All right, so this is your electrical rules checker. It will make sure that all these components are working as they're supposed to with no faults. Click run electrical check, And if there's any errors, you'll have something pop up on this screen. I'm clicking run ERC, and as you can see, there's 0 errors, 0 warnings. That means there's no fault with my design. Okay. All right. One thing I forgot to tell you is that if you do want to add some mounting holes, you are going to click A, add for symbol, look for a mounting hole. Okay. And you're going to be given a few options here. Mounting hole without a connection, mounting hole with a connection. We're going to do mounting hole without a connection, where you want the hole to be. This is so that you can essentially mount it to any object that you're going to be integrating this with. Let's say a remote control or something, you know. So the reason you do this is so that the PCB doesn't move around. So you can have it as some sort of a holder. Okay, you're going to be able to insert a pin to keep the PCB in place. That is the purpose of it. And as we were dealing with footprints before, you will right click it, click properties, footprint, and you're gonna click the library symbol. And now you're gonna search up mounting hole. And as you can see, here's a reference on the right side showing you how the hole will look like. And on the description, you can see measurements of what size the hole is going to be. And now you can again copy and paste. And they even tell you the position of where the hole is located. Okay. All right. Now that you've done that, we can move on. All right. Now here comes the most frustrating part, is that once you finish designing and drawing your PCB, you have to transfer it over to the actual PCB editor. Okay. And the way you do it is by clicking Tools, click Update PCB from Schematic. And you will select relink footprints to schematic symbols. Yeah, so once you click update PCB, you will find that you have lost the layout of how your PCB looks like. What you have to do is essentially drag all the components back to where you want them to be, or how they look like in your schematic. All right, so now you're gonna draw the same sized layout. You're gonna click select tool, and you're gonna drag every item back to their original spot. Now that you have every component back in their original spot, as you can see, even the traces are missing now. We're gonna add the tracks back to how they used to be. And you can actually see one good thing about this is that when you click track and attach it to your battery, to your power source, you can see the highlighted end of the resistor that you originally assigned it to, meaning that I need to rotate this resistor as it is in the wrong spot. So we're gonna cancel this for now, and we're gonna select the resistor, the component, and rotate it by clicking R. And if I select the tracks now, you see it's in more convenient spot for me. So this track right here, this is where your power is going to be traveling to, from the battery to the resistor to the LED. So we're going to click track again, click this portion of the resistor, boom. And now the LED has to go back to your negative. And there you go. Here's a connection made. I'm just now going to quickly connect all the other components back to how they used to be. All right, now that we finished designing our PCB, we need to export a few things. We need to export the bill of material, meaning that we need to have all the components listed in an Excel format so that you can upload it to PCBWay so they know exactly which components you're needing. We also need to export all the layers of your actual PCB. This is how they're going to manufacture it based on the information that you provide them with. They're needing also a centroid file, which essentially shows the location of each and every component. That this way they're going to be able to correctly place the components based on where you want them to be. They're not going to look for them. They're not going to read through your schematics. They just need to have that centroid file so they can properly allocate where the location of the components need to be. We're going to begin by clicking File, Fabrication Outputs, Bill of Material. Save this file, this .csv file that you can open using Microsoft Excel, somewhere in the folder where you're designing your PCB. This way it doesn't get lost. Then we're going to click File again. We're going to click Fabrication Outputs, and we're going to click Component Placement, the .pos file, which is your centroid file, and then click Generate Position File. Now the centroid file is saved in the folder where your schematic is found. We can see it here. That is your POS file. Alright, so we now have bill of material, we have your centroid file. Now we need to export the actual PCB itself. You will need to export a Gerber file, which is can be found by clicking File, Fabrication Outputs, and typically it's the first one here, Gerber. Okay. Now you will see on the left side there's a bunch of layers. Alright, since we're dealing with only the top layer, we haven't designed anything on the back, we can remove the back layer, the back paste, the back silk screen, the back mask. So what we're left with is front layer, the front paste, front silk screen, front mask, edge cuts. Edge cuts is your actual outer layer of your PCB, okay? That is your shape. That's your actual physical shape of your design, okay? So we have 1, 2, 3, 4, 5 layers, okay? And now we're going to select output directory to be in the same folder where you're designing your PCB. Click generate drill files also, okay? That is also needed for PCBWay to be able to drill the holes needed for your PCB. And then you click generate drill file. Okay, so a drill file has been made. Close. Now for you to output all your layers for your PCB, click plot, and it's done. Alright, now I would suggest you open up the folder where you saved everything. Just double check to make sure you have all the files. Okay, now I'm going to show you how to actually upload all the files that you exported, and so that PCBWay can start assembling and manufacturing your PCB. So you will click PCB instant quote. Alright, you will head over to quick order PCB. You will add your Gerber file. To do that, find the folder where you saved everything. You need to compress them into a zip file. Select your edge cuts file, your front layer file, your mask file, your paste file, and your silk screen file, okay? I would also include the POS file and the drill file. Right click and then compress to zip file. We will then go back to PCB website, click add Gerber file, find the zip file, click open. You can click online Gerber viewer to make sure that your PCB looks all right. You can click layers to see each and every layer. You can see where the drill holes are going to be. You can see where the silk screen is going to be. You can see where the solder points are going to be. Alright, so going back to the order screen, you see the size of your PCB. Quantities, you can select as much as 10,000. That's how many PCBs they're going to manufacture. Minimum 5. Minimum hole size, solder mask, you can select different colors. Silk screen can be yellow, black, white. This is the service I like the most, the assembly service. They actually put together all the components for you so that you don't have to do it yourself. Also, I like this particular service they offer. Pay attention. It says, do you accept alternative substitutes made in China? So you will select no or yes. Yes, meaning that if they are not able to source the material that you've selected within your design, they will give you different alternatives. Okay. Here you will have to also insert how many unique parts there are. So we have a resistor, we have LED light, and we have the battery holder. So 3 unique parts. And then we have a function test. Function test essentially means that once your PCB is manufactured and finished, PCBWay will test your component for you. Once you finish making your selections, then you can proceed with your quote. A member from PCBWay will contact you, making sure that all the files are in order so you can proceed with your purchase. For your first order, you can get $5 off by following my referral link down in the description. I hope that in today's video, I managed to teach you that designing your own electronics isn't that difficult. Let me know down in the comments if you have any questions about the process. I thank you for watching this video, and I'll see you in the next one.